Hi, my name is Shrikant Rathod. In this video, I'm gonna revise some basic math concepts which we already learned in schools. These fundamentals are very important to crack any competitive exams which includes math such as SAT, ACT, GMAT, GRE, CAT, etc. Any competitive exams which involves the math, these are the basic fundamentals what you need to know, right? So when we think about maths, it comes in our mind that we have to do something with the numbers. So it's very important to know how the numbers are categorized. In general, numbers are divided into two types. The one type it's called imaginary numbers, and other type is called real numbers. Let's see what you mean these. What are imaginary numbers now? Any number multiplied by I, that is imaginary unit, are said to be imaginary numbers. And these numbers are not a part of our everyday life. So in general, the square root of any negative numbers are said to be an imaginary number. I can write this square root of negative 2 can be written as square root of 2 times square root of negative 1. So that's a square root of 2 square root of 2 times I. So this number square root of 2 got multiplied by the imaginary term I. That's why the square root of negative 2 is said to be an imaginary number, or any other number, square root of negative 10, square root of negative 3, etc. These all are imaginary numbers. Now, what do you mean by real number? A simple definition is any number which exists on a number line are said to be real numbers. So let me draw a number line and represent. Let's say this is 0, 1, 2, 3, and so on, negative 1, negative 2, negative 3, and so on. If I say number between 0 and 1, I can say, let's say example 0.5. This representation we say it's a decimal, right? This is the decimal representation. If I'm saying between 1 and 2 approximately, I can write in terms of fraction as 3 by 2. That's equivalent to 1.5. This type representation is the fraction, or we can also say a rational. Let's say somewhere over here, the value of pi is 22 by 7. That's approximately 3.142 something. So this type of representing a number is said to be irrational numbers. So look at on the number line. If I'm talking about all the complete numbers, that is negative, 0 and positive, these are said to be an integers. So look at, if I just say only the number which are multiples of 2, this is 0, 2, positive 2, negative 2, and so on. These are said to be even integers. These are called even integers. And the number which are not multiple of 2 are said to be odd integers. So these all numbers are said to be odd integers. So in general, I can say number which can be represented on the number line, as I said, are said to be real numbers. Now, real numbers are further categorized into two types. So which are those? As we mentioned, rational numbers and irrational. Let's see what these mean. A rational number are those any number which can be represented in the form of a fraction, that is whose numerator and the denominator both are integers. So in general, any number which can be represented in the form provided q is not equal to 0 are said to be a rational number or rational representation. It's basically a fractional representation. So such numbers are said to be a rational number. So example, I say 2/3, 3/5, 2. Yes, 2 is a rational number because 2 can be written as 2 by 1, isn't it? So all these numbers are said to be rational numbers. Now, what do you mean by irrational numbers now? Numbers which can't be expressed as a fraction, whose numerator and the denominator are integer. Even though you are writing the numerator and the denominator as an integer, the number which can't be expressed as a fraction. So example of such, it's going to be 22 by 7. So numerator and denominator both are integer. So 22 by 7 in common we write it as a pi, isn't it? So pi meaning 22 by 7. So its value is 3.142753345 infinitely. It will go till infinity. This type of numbers are said to be irrational number. After decimal point, the numbers are repeating till infinity. So continuing till infinity, right? So such are irrational. Square root of any non-perfect square number are said to be irrational. Example, root 2, root 3, root 5. These all are irrational numbers. Irrational numbers. All right. Okay. Let's go next. Integers. Integer consists of those numbers which are multiples of 1. Right. So any number which are multiples of 1 are said to be integers. -3, 0, 5, 8, 30, etc. All these numbers are the complete numbers, whether it may be negative, 0 or positive, are said to be integers. All the number left side of the 0, which are these, are the negative integers. All the number which are right side of the 0 are positive integer. And look at here, when you are going further for the negative numbers, when you are going from the left side to the right, so their values are increasing left to right, their values are increasing. But when values are increasing in this way, so we can say -100 is smaller than -20. So on a number line, if you go from left to right, the value of the number increases in general, I can say. Consecutive integers. Integers that follow one another without skipping any integers. 1, 2, 3, 4, 5. These are our consecutive integers. I can say -10, -9, -8, -7. These are integers. Or I can also say 100, 101, 102, 103, and so on. These are our consecutive integers. In general, if you don't know where your integer or the consecutive integers from where it is starting, whether it's starting with 1 or 10 or 100, if you don't know, and there are certain questions you expect on this way, so it's better to consider the first term of your integer as x, then your next term is going to be x plus 1, your next term is going to be x plus 2, x plus 3, and so on. Why? Because number which we are representing this pattern, the next number is 1 greater than the previous one, next number is 1 greater than the previous one. If you take the difference between 2 and 1, so the difference is 1. So again you take the difference between 3 and 2, so difference is 1. So the number is every time getting increased by 1. Such numbers are said to be a consecutive integers. Again, they can be a question based on the consecutive negative integers or consecutive positive integers. So depending upon the sign, they may also ask you question about. Okay, right. Let's go with non-integers. As the name itself says, non-integers are those which doesn't, opposite to the integers. I can say the decimal or fractional representation. These all are non-integers, right? Evenly spaced numbers. Which type of numbers are said to be an evenly spaced numbers now? Let me represent the example again. 1, 4, 7, 10, 13, 16, and so on. Such numbers are called evenly spaced. So why? If you take the difference between the higher and the lower number, every time the difference should be fixed. 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. So the difference is fixed in this pattern. Such numbers are said to be evenly spaced numbers. So the numbers can also be, let's take 100, 1 of 5, 1 of 10, 115, and so on. So these are the difference between them, it's a 5, 5, 5, and so on. These are evenly spaced numbers. The another word in maths what we can also use for the evenly spaced numbers are in arithmetic sequence. Arithmetic sequence. So these numbers are said to be evenly spaced. Of course, there are like many things needs to be done. Find the first term, last term, sum of those. This all will be discussed later. This is just I'm giving an introduction what these evenly spaced numbers are. Whole numbers. Non-negative integers are said to be whole numbers, including 0. So I can say 0, 1, 2, 3, 4, 5, etc. till infinity. Non-negative numbers, including 0, are said to be whole numbers. Remember, 0 is neither negative nor positive. 0 has no sign, it's a neutral. But when I'm saying whole number are the non-negative, means we can consider the 0 as the whole number because it's a non-negative number. Now, counting numbers. Counting numbers are the subset of whole numbers which excludes 0. So any number the which excludes 0 and the positive number, we can say those are said to be counting numbers. 1, 2, 3, 4, 5, all positive number excluding 0 are said to be counting numbers. The another word for the counting number we can say natural numbers. Natural numbers are said to be counting numbers. Remember when the school days our teacher used to say us while counting the number we used to start from 1, 2, 3 like that. We never started from 0, isn't it? So that's why counting number always start with 1, 2, 3, 4 and so on, and those are positive numbers. Right. Let's talk about factors and multiples. So what you mean by factors? So another word for the factor is divisor. What do you mean by factors or divisors? A factor is an integer that can be divided evenly into another integer. Evenly means that there is no remainder. Okay, let me make you further simple. Let's take an example. I have a number 12. Tell me 12 is divisible by which all the numbers? 12 is divisible by 1, 2, 3, 4, 6 and the 12 itself, isn't it? So these all numbers are called factors of 12, or I can say the divisor of 12. So if you divide 12 by any of these number, the remainder is 0. Such numbers are said to be factors. Okay. Now, what are the multiples then? Multiples. Multiples are the numbers that result from a given integer being multiplied by another integer. Okay, let me make it further simple. What are the multiples of, let's take 12. What are the multiples of 12? The 12s are 12, 24, 36, 48, 60, and so on. 12, 24, 36, 48, 60, and so on. These all numbers are multiples of 12. Got it? So factor meaning the number which can divide, and the multiples meaning the number which got multiplied by other number, like 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36. Means every time 12 is getting multiplied by other numbers like 1, 2, 3, 4, and so on. So those resulting numbers are said to be the multiples of 12. All right, let's go to the next part, prime and composite numbers. So prime and composite numbers are the very important topic as per the competitive exam concern, because prime is the major uh, unit which we consider in GMAT and GRE, and of course the other exams as well. So it's very important to know what are the prime numbers and what are the composite numbers. I know you guys already know what is the definition of prime and composite and all. As I told, I'm just revising all the concepts. So what do you mean by prime numbers? Different people give a different definitions. A prime numbers are a subset of counting numbers. They include those non-negative integers which have two and only two factors, that is 1 and the number itself. Let me tell you in the simple word. Any number which can be divisible by 1 and itself, such numbers are called prime numbers. So what are those numbers now? If I make a list of such numbers, so 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and so on. These are the first 10 prime numbers which I have written. So why I am saying that? Because 2 is divisible by 1 and 2 itself. 3 is divisible by 1 and 3 itself. 5 is divisible by 1 and 5 itself, and so on. So any number, I can say any number divisible by 1 and itself. Divisible by 1 and itself are prime numbers. Okay, now if you look at to this pattern, you need to conclude very important points here. The first thing what you need to conclude here is what you see in this pattern. Observe, pause the video, observe carefully and check it. What we can see here is 2 is the smallest prime number and 2 is the only even prime number, isn't it? So 2 is smallest and only even prime. All the numbers after 2 are odd numbers, is it? So let's say in a paper, if you are getting some kind of question like that, prime numbers greater than 2, or they may say x and y are the prime numbers greater than 2. It means they are talking about indirectly about the odd numbers, isn't it? All the prime numbers which are greater than 2 are said to be odd numbers, isn't it? Now, they may also say the smallest odd prime. The smallest odd prime. So which one is the smallest odd prime here? 3. The smallest second odd prime. The smallest second, rather than saying smallest odd prime, they may say, yeah, the smallest second odd prime, the smallest third odd prime. This is, so this is the smallest second odd prime, 7 is the smallest third odd prime, and so on. They may also say the smallest two-digit prime number. The smallest two-digit prime number is this. 11 is the smallest two-digit prime number, and so on. Of course, if you know the basic steps related to this, then you will able to analyze and understand the question what they're expecting you to do. Okay, right. So the other thing what you can observe here in this pattern, okay, so before going to that, my question is negative 2 a prime? Is negative 2 a prime? Pause the video, question yourself, try to analyze whether it is prime or not. Okay? Okay, let me explain. Negative 2 is not a prime number. Why? Because negative 2, what are the factors of negative 2? Means negative 2 is divisible by negative 2, negative 1, 1 and 2, isn't it? This number has more than two factors, and the number which has more than two factors are not prime. To become a prime, we have to have only two factors, 1 and the number itself. So that's why negative 2 is not a prime. Negative 2 is not a prime number. Okay, right. So let me ask you one more question. One more question here. Okay, let me write here. So it's better. Let me just write. Let me just write here. Question is is positive 1 a prime? Is positive 1 a prime? Question. Okay. Okay. 1 or positive 1 is not a prime. Why? 1 is divisible by 1 only. There are no other number which can divide 1. So that's why to become a prime it has to has two factor, 1 and the number itself. The 1 is divisible by 1 only. That's why 1 is not a prime number. Then it may come in your mind, is negative 1 a prime? Because negative 1 has the two factors. What are those? 1 and negative 1. Now you may think, is negative 1 is a prime? Then I say negative 1 is still not a prime, because when you multiply any number by 1 or negative 1, the number just changes its sign. So if you are multiplying any number by positive 1, the number remains as it is. If you are multiplying any number or dividing any number by negative 1, the number becomes negative. It just changes its sign. So it won't be another value, isn't it? So that's why 1 is said to be a unique number. It's not a prime number. So remember, 1 and the negative 1 are not a prime numbers. So the second important point what I wanted to conclude here is, from all this discussion we say negative 2 is not a prime, negative 1 is not a prime, and so on. So we can make a conclusion here is positive, prime numbers are positive numbers, isn't it? Prime numbers are positive numbers. When they are saying in questions like they say prime numbers, you should think that the numbers are positive, even though they say the prime integers or prime, doesn't matter. When they are using the word prime numbers or like that, the numbers are positive numbers. Okay, right. Now what do you mean by composite number? Now composite numbers. Now what do you mean by composite numbers? The composite numbers are the number which has more than two factors. Example, I can say 4. If I write 4 is divisible by which are the number? 4 is divisible by 1, 2 and 4. 6 is divisible by 1, 2, 3 and 6. Right? 9 is divisible by 1, 3 and 9. Look at here, all these number has more than two factors. So all these numbers are said to be composite numbers. Okay, let's go with even and odd numbers. As we say, the even numbers, the number which are multiples of 2 are said to be even number, and the number which are not multiple of 2 are said to be an odd number. In general, even number we can write here as 2k, because it's a multiple of 2, where k is any integer, even integer I can say, where k is any integer. So like I can say, and the value of k may be 1 2 3 4 or negative including 0 also. So 2 times 0 0, 2 times 1 2, 2 times 2 4, 2 times 3 6 and so on. These all are even, isn't it? Which are multiples of 2. These all are even integers or even numbers. So what do you mean by now? Odd integers now. Simple. Odd numbers or odd integer which are not multiple of 2 are said to be odd integer. In general, odd integer we can write it as 2k plus or minus 1 or 2k plus or minus 3 and so on. It means if you are adding 1 to the even number or you are subtracting 1 from the even number, your result is odd, right? Or you are adding 3 to the even number, or if you are subtracting 3 from the even number, your result is odd. That's the reason I can write it in this way, general. Or simple definition, the number which are not multiples of 2 are said to be an odd numbers or odd integers. Now let's see some basic math operations which can be done on this even and the odd numbers. Let me erase this, and we'll see further detail about the even and odd. All right. Oops, it takes some longer time, so then we have to make efficient use of space now then. All right, let me just erase it. Okay, got it. It's almost done. Great. Yeah. Okay, so great. When we are talking about the numbers, as we said, even and odd, it's very important to know how we can consider them when we do some basic math operation like addition or subtraction. Okay, what happens when you add even number with add or subtract even number with even number or even with odd? Let's see, even number, whether you add or subtract it with the another even number, your result is even. Example, I can say 2 plus 2 is 4, isn't it? Even number added or subtracted with the odd number, your result is what? Odd. Example, I can say 2 plus 3, it's 5. This is example, okay? And odd number added or subtracted with another odd number is even. Example, I can say 3 plus 5 is 8, where 8 is even number, isn't it? So these are the things what we need to know. Now let's see about the multiplication. Let's see about the what happens when you multiply. Multiplication or multiply. Even number multiplied with another even number, your result is even. Example, 2 times 2, that gives me 4. Even number multiplied by odd number, the result is even. Example, I can say 2 times 3, that gives me 6, which is even. Odd number multiplied by another odd number, your result is odd. Remember, when we added odd with another odd, we got the result as even, but when you are multiplying two odd number, the result is odd. Example, I can say 3 times 5 is equals to 15. If you are not able to memorize these rules or revise something, whenever they say multiplication of odd number or multiplication of even number or even and odd, just take the small and the simple even and odd number and do the operations like multiplication or other if thing they are asking. Okay, so these are the basic things what we need to know. So note here, division of the two integers can result into an even, odd, or a fraction. So there is nothing such rule related with the division of the even or odd integers. Okay, right. Now let's go next topic, that's the positive and the negative numbers. Positive numbers which has like positive sign, we say a positive number is a real number that is greater than 0. In other word, I can say a negative number is a real number that is smaller than 0. The number all like the right side of the 0 all are positive and the left side of the 0 are negative on a number line, right? So but remember, 0 is neither positive nor negative. All right. Okay, so it's very important, sorry, it's very important to know what happens when you multiply or divide with positive or negative numbers. Okay, now what happens? Positive number, any positive number multiplied with another positive number, your result is positive, isn't it? Positive number multiplied by negative, your result is negative. Negative number multiplied by positive, your result is negative. Negative number multiplied by negative, result is positive. So look at, if you are multiplying two number which has the same sign, either negative or positive, their result is always going to be positive. But if you are multiplying the two numbers which has opposite sign, one is positive, one is negative, or one is negative and another one is positive, they turns to be a negative numbers. Okay, that same thing holds true to the division as well. Positive divided by positive number, the result is positive. Positive by negative, it's negative. Or negative by positive, the number result is negative. Negative number by negative number, the result is positive. Same thing, whether it is multiplication or the division, it's gonna be the same, positive or negative. Right. So it's very important, apart from this, about the positive and negative number, it's very important to know negative number to the odd power. Negative number to the odd power is always what? Negative. This kind of tricks you require especially when you are working with the GMAT, GRE or CAT. Okay. So negative number with the odd power are said to be negative. Negative number to the even power are the, and I'm talking about the sign of this entire result. Okay, don't get confused, I'm talking about the what is the negative number to the odd, what would be the sign of this negative number to the odd power, the sign of the result, it's negative. The negative number to the even power, sign of this entire result, it's gonna be positive. Okay, so let me just represent example. Negative 2 to the power 3, what it is? Negative 2 times negative 2 times negative 2, correct? What is this entire thing is given? Negative times negative is positive, 2 times 2 is 4, positive 4 times negative 2, it's going to be negative 8, isn't it? So that's the sign is going to be negative as the power here is odd. Same thing if I am saying negative 2 to the power 2, let's take example. Negative 2 times negative 2. Negative times negative is positive. See, negative times negative is positive. That's why negative 2 times negative 2 it's going to be, first you have to multiply sign, then you have to multiply number. 2 times 2 is going to be 4, the positive 4. So this is very important. Okay, right. Fractions and decimals. So as we know that the fraction can be represented in this form, p by q, where p is called the numerator, q is called the denominator. Okay, depending on this type of representation, it's called a fraction representation or fractional representation. Okay, so fractions are of different types. So the first type, I can say a proper fraction. Proper fraction. Which type of fractions are said to be a proper fraction? Whose numerator are smaller than the denominator. So if I am saying this is the numerator and this is the denominator, or whose denominator is greater than the numerator, are said to be a proper fraction. Example, 2/3, right? This numerator is 2 and the denominator is 3. So numerator is smaller than the denominator. Such fractions are called proper fraction. Another one is improper fraction. Improper fraction is exactly opposite, whose numerator is greater than the denominator. Example, I just say 3/2. This is called improper fraction. And the third type we can say is mixed fraction. Okay, so mixed fraction. So mixed fraction who has the complete number including the fractional part. So I can say 1 2/3. 1 is the complete number, this is 1 2/3. So this is called the mixed fraction. This can also be written as 1 plus 2/3 when you simplify. Okay, now it's important to know what actually the fraction as I told here. Let me just draw, make a 3 part of this, because the always the denominator says the something has been how many parts. Let's take the denominator is like the 3. So this is, let's take, this is the pizza and you are dividing into 3 parts. So you are sharing this pizza into a 3 part, equally with the 3 friends. So if I'm representing here 2/3, meaning this portion, like 2 of your 3 friends are taking this portion. So that is, this fraction we represent it as 2/3. So 2 out of 3, 2 has been taken, 1 is left. So this 2/3 has been taken out and the 1/3 which is left, right? So this is how do we represent the fraction. Anyway, so we'll be going in a detail when we start with the actual courses related with this all competitive exams. I'll be discussing in more detail. So as this is just a basic, right? So these are all called fractions, and doing the some basic operations on the fractions and those that's we need to consider. Now when I do like when we discuss about the fractions, so we need to do some we need to know how like some basic operation has to be performed on the fraction. So let's take, what are the things we need to consider when you do addition or subtraction with a fraction. Addition or subtraction with a fraction. So let's take an example. If I have a number 2/3 plus 3/2 minus 4/5, example. Okay, so this is the number. I have to perform a certain, I have to do what is the simple form of this fraction. So I have to do what would be the simple form. So what I need to do is, while doing addition or subtraction of the fraction, first thing remember, you have to make a common denominator. You have to make a common denominator for all the 3. Alright, so here denominator here is 3, here is 2, and here it is 5. Then how you can make a common denominator? Because all these numbers are prime numbers, right? So all these numbers are prime numbers. To make a common denominator, so you just need to multiply them. So that is what we say, we are finding the least common factor. Hope you guys remember, or lowest common, least common factor, we can say LCM, right? So what we do, so as these numbers are not multiple of each other, you just need to multiply them. 2 times 3 times 5, what we gonna get? 2 times 3, it's gonna be 6. 6 times of 5, it's gonna be 30. So because 30 is the first common number which appears in the 2 times table, 3 times table, or 5 times table if you write, right? So that's said to be a least common multiple, right? Then as I told, we have to make a denominator to be 30. Then what should I do? You have to multiply these numbers, you have to multiply the denominator to make to be 30. So 3 is multiplied by what number to become a 30? So 3 I have to multiply by 10, isn't it? So multiply, if you are multiplying by 10 by denominator, you have to multiply by the same number to the numerator as well. Got it? So here I have 2. 2 multiplied by what number gives you 30? Multiply by 15. 15. 15. So here 5 multiplied by what number gives you 30 now? 5 multiplied by 6 times by 6. So further we write it in the simplest. 2 times 10, it's going to be 20 over 30 plus 15 times 3, it's going to be 45 over 30 minus 4 times 6. What it is? 24 over 30. So look at, we got the 30 as a common denominator now. So I can write it as 30. So we can say 20 plus 45 minus 24. So this is equivalent to what? 20 plus 45 minus 24 can be written as 41 by 30, isn't it? So this all result gives you 41 by 30. If it is possible for you to simplify, simplify it, or keep it as it is. This is how you add or subtract with the fraction. Got it? Now let's see some other operations which is related with the fraction, that is multiplication. Multiplication is the simplest. If I'm saying 2/3 multiplied by, let's take 9 by 12 example, okay, to 2/3 multiplied by 9 by 12. So most student, they say like, they multiply 2 times 9, then they multiply 3 times 12, and then they will further simplify and so on. But I would suggest, whenever there is a multiplication, it's not necessary the denominator is under this one or the second term, it doesn't matter. Multiplication meaning is this entire thing is considered to be a single term. Plus or minus sign separates the term, and the multiplication or the division sign is considered to be a single, right? So I can further simplify 3 times 1, 3 times 3 is said to be 9. So how do I am doing that? Because when you read the 3 times table, 3 times 1 gives me 3, 3 times 3 gives me 9. So I can reduce the 3 and 9 in terms of 1 and 3. That's what I'm doing. 3 times 1 is 3, 3 times 3 is 9. So further I can, because 2 and the 12, because 12 is multiple of 2, right? So I can say 2 times 1, or 2 divided by 2 is 1. 12 divided by 2 is 6. It's, I can say like 2 divided by 2 is, 2 divided by 2 is 1. 2 divided by 2 is 1, and 12 divided by 2 is 6. That's what I'm. So then after dividing, what you left with, if you can further divide them or simplify them, yes, simplify it. If not, then multiply numerator with numerator and the denominator with denominator. After simplifying, we got it as 3 in the numerator and the 6 in the denominator. 3, let's divide, because 3 and 6, 6 comes in the 3 table. So what I do, 3 divided by 3 gives me 1, and 3 divided by 6 divided by 3 gives me 2, isn't it? So divide 6 by 3, divide 3 by 3, then we got it like 1 by 2. Now nothing is multiple of each other. 1 times 1 it's gonna be 1, 1 times 2 it's gonna be 2. This entire result of multiplication is equivalent to half. This is how do we do the multiplication in fraction. Okay, all right, so let's do with the division as well. Let's do the division. Let's take an example, dividing fractions. Let's take an example. If I have a number 5 by 4 divided by, let's take 7 by 8. Okay, this can also be represented as 5 by 4, this entire thing divided by 7 by 8, just a notation. Okay, now how do you do this division? So whenever you do a division of a fraction, remember one thing, keep the first expression as it is, that is 5 by 4 as it is, and while converting this division into a multiplication, you have to flip the numbers. Flip the number meaning the denominator will go to the up and the numerator will come to the down. So the division sign will be converted into multiplication by flipping the numbers. So I can say 8 by 7. So that's how do we represent. Now this is how do we convert it into multiplication. Now follow the rule of multiplication. If they are possible to simplify or reduce them, reduce it. If not, just multiply numerator with numerator and denominator with the denominator. Okay, okay, let's what we do now. Yes, because 4 and 8 comes, like 8 comes in the 4 times table, then I have to do 4 divided by 4, which gives me 1. 8 divided by 4, which gives me 2. So now, is there any 5 and 7 appears in the same times table? No, all the numbers are different. Then what I do, 5 times 2 is 10 by 7. This is the result of the division which they have given. Okay, this is how do we follow the division of fractions. All right. All right, so let's go to the other topic, that is, let's talk about the another point, important point relating with the fraction. Convert mixed fraction to improper fraction. So what if the question includes the mixed fraction, and how do you make use of it? So example, if the question includes like 2 1 2 and let's take 2/3 example, as I told, this is also equivalent to 2 plus 2/3, right? So how do we convert this then? Now I told you, like whenever you are adding or subtracting the fractions, you have to make the common denominator 2 plus 2/3. Now what is the denominator of these two? Always 1. Any number which are multiple of 1 or divisible by 1, right? The denominator here is 1. So I have to make the denominator here is also to be 3, because here it is 3. So what should I do now? You have to multiply the denominator by 3, and also you have to multiply this one is by 3. So then further, then you multiply 2 times 3 is gonna be 6. 6 by 3 plus 2/3 as it is. Now look what I do. I can take 3 as a common denominator. 6 plus 2, 8 by 3. So 2 2/3 can be equivalent to 8 by 3. This is how we convert a mixed fraction to improper. What I'm saying, why I'm saying it is improper, because the numerator is greater than the denominator. That's how do, whenever you convert a mixed fraction, always the result is the improper fraction only. Okay, all right, now let's go to the next part. That's what we included, that is the decimal. Which type of numbers are said to be a decimal numbers? A number which includes a decimal point in between are said to be decimal numbers. If I am writing example, 1 2.3456, something like this. As this number includes a decimal point in between, these numbers are said to be a decimal number. And based on that, if we give the position of the number, all the complete numbers are said to be in the tens, hundreds or thousands and so on, but the number after decimal are said to be in the tenths place, hundreds place, thousands place and so on. It meaning tens means after the decimal point the number are getting divided by either 10, 100, 1000, 10,000 and so on. So that's why if I'm talking about the place value, this can be said to be tens place. It meaning 1/10. 3 by 10, that gives you 0.3, isn't it? If I'm talking about this one, it can be said hundredths place. So it's gonna be 1 divided by 100. If you are dividing this 4 by 100, you will be getting 0.04. This is said to be in thousands place, that is times, that's the number, right? So tens, hundreds, thousands, 10,000s and so on. But when I'm talking about the complete number, this is called ones place, ones or unit place. This number is called tens. There is difference between tens and tens, okay? Tens place. Tens place meaning this number, 1 multiplied by 10, that gives you the the 10 plus 2, that gives you total as the 12. This is the unit place, tens place, 100 place, 1000 place and so on. This is how do we represent the decimals. Okay, adding, subtracting, multiplication, division of the decimals will be discussed in detail when we go with the topic. Very important thing what we need to know here about the decimal is rounding the decimals. Rounding decimals to the nearest values. Okay, so when you round the decimal to the nearest value, so let's take an example. If I have 12.345, 12.344, 12.337, example something. If I say round it to the two decimal places, round to two decimal place, or rounded to the, or rather than saying rounded to the two decimal place, they may say rounded to the nearest thousands or nearest tens or hundreds, rounded to the two decimal place, it's the same, two decimal, or rounded to the nearest hundreds, same thing. Okay, decimal places. So what we can say, rounded to the two decimal places means after decimal there should be only two numbers. Now to say it like two numbers, so this is the tens place and hundred place. You have to look at to this place number, that is this is the second decimal place. If the number next to that one is 5 or greater than or equal to 5, if the number next to that one is, let's say x is the number greater than, next to the 4, if that number is greater than or equal to 5, you have to add 1 to this number. You have to add 1 to this number. If I say rounded this one to the nearest hundreds, can be done as 12.35. Why? 4 plus 1 gives me 5, because the number next to it is greater than or equal to 5, isn't it? If it is greater than or equal to 5, you have to add 1 to that. Let's see here. Again, rounding to the 2 decimal place. If look at to the next number is smaller than 5. If the next number is smaller than 5, then don't do anything. You can just you can represent 12.34 itself. Don't add any number to the 4. Let's represent 12.34 itself. Let's say again here, okay, 12.337 rounded to the 2 decimal place or nearest hundreds. So you have to look at to the hundreds place. Look at to the next number is greater than 5. If number greater than 5, then you have to write it as 12.3. You have to add 1 to this 3, right? That's why it becomes 12.35. This is how the number are rounded to the nearest tens, hundred, thousands based on what the question is asked. Okay, right. The last topic, of course, is not a topic, but this is just an order of operation what we need to follow when you are working on the some math concepts. So these are said to be a BODMAS, or we can say different another name for the BODMAS, we can also say it as the PEMDAS, right? So what does the BODMAS says? This explains the order in which the math operations can be performed, that is the division, multiplication, addition, subtraction, and so on. So let's say B stands here for the brackets, and the order of the brackets what we need to follow is, I have to give preference first to the the closing brackets. Then this means first you have to go with these brackets, then you have to follow this, then you have to follow this. This is the order, or we can also say that as P, that is the parenthesis. Second one is O, that stands for orders of. Orders of meaning whether it is an exponent, x square, or x cube or something, whether that bracket it got multiplied by the square, cube, something like that, or we can say exponents, right? And next one is the division. The first preference will be given to division, that is division or division like this, or then next preference will be given to the multiplication. That's, we can say it's like multiplication, or I can represent it with the star, right? Then next preference will be given to the addition, that's plus. Then last comes with the subtraction, that is minus. So while doing the certain basic math operation, we need to follow these orders. So that's, it's very important to know the rule, how the the orders of working on the numbers. All the calculator implemented by using the BODMAS, because now the education is mostly allowing to use the calculator for the from the very beginning of the schools, I would say, like grade 6, 7 and all. So that's why the students are not aware of how this works. So but it's, if you are preparing for the any competitive exams, so I would prefer you should know a detailed basic about, okay, because there are some exams which they don't allow you to use a calculator. If I'm talking in terms of sat, there are like two sections for the math. One is with calculator and one is without calculator. So it's a good practice to solve the questions and know the basics with without using the calculators. Okay, let me take one example relating with the BODMAS. Let me take here, if I say, let me just change the color, let me just, okay, if I have an expression something like this, 5 minus 3 square plus 2 times, it's a multiplication, okay, let me just write 2 times 9 minus 5 square. This is divided by 2, right? This is divided by 2. I can do all this, the steps, in a multiple ways, in the sense I can multiply, divide by 2, something something, I can do it together. But let me show this one with how the BODMAS rule works. So first I have to give the preference to the brackets. So which are the terms which has the brackets? And this I have to first select those brackets, and I have to do the operation of order, that is the parenthesis. So first we have to simplify the brackets. So 5 minus 3 is what? That gives me the result here as 2. So it's a square plus 2 times 9 minus 5, that gives me 4. It's a square divided by 2. Okay, now I simplified with the brackets. Now I have to go with the operands. So 2 square is 4 plus 2 times, what is 4 square is 16 divided by 2, isn't it? So before going the multiplication, I have to do the division of this. So 4 plus 2 times 16 divided by 2. So 16 divided by 2 is 8, because 16 divided by 2, that gives me 8, that is 16 by 2, 8. Okay, so that's what I'm just writing it as 8. So 4 plus, what do we need to do now? Before adding, don't do it like 4 plus 2 is 6, 6 times 8. No, you have to follow the first order as the multiplication. 8 times 2, it's gonna be 16. 16 plus 4, what the result we gonna get here? It's the last step is gonna be 20. So this is how the BODMAS or the PEMDAS works. Okay. All right, I think this is all what you need to know about the basics. This is the first video which I make. Very soon I'm gonna make the second part of this, which includes like the other important topics which you need to know for the competitive exams, like the inequalities and absolute values, percentages, and other things. So thank you so much for watching, and if you have any suggestions or questions or any feedback, please write it into the comment section, or you can send me an email to the virtualguru@gmail.com, so that I'll definitely get back to you and clarify your doubts. Thank you so much for watching.